So, welcome to this episode of Seen and Solved. I'm Tim Pennington, editor in chief at finishingandcoating.com. Today, we're talking with Robin Deal, who's the product manager for the AquaPure line at Hubbard-Hall. And today, we're going to be talking about wastewater treatment. I'm Tim Pennington, and you're listening to Seen and Solved, brought to you by Hubbard-Hall. Better results, less chemistry. And the topic that is going to be really what Robin gives. Robin, you give this talk a lot when you're out in some of the chapters and associations. 7 things I wish I knew about wastewater treatment, correct?
I do give it. A couple of other smaller local chapters have asked for it. I think it's something that we kind of change up a little bit to keep it interesting, but the 7 key points are always there for us.
My publication, we've had in the past month 2 incidents where we've had shops who sort of weren't paying too close of attention to their wastewater. There was a shop where 2 owners are going to be actually pled guilty to sort of subverting the proper wastewater treatment under federal charges, and they're now facing felonies, and they'll be sentenced in January. And then we had another incident where a large, very large operation in Michigan had I guess an accidental leak, so to speak, and now the FBI is involved, and the state investigators are involved, and they're going to be facing a tremendous uphill battle in the next year or so to kind of clear their name on that, don't you think?
Definitely. We've seen an increase in incidences with manufacturers not fully understanding laws and regulations around their industrial wastewater treatment across the Southeast as well as the Midwest. And even out in California, we're seeing an increase in these types of incidences where I don't think that most manufacturers understand how critical it is that they follow the law for their pre-treat permits. I think because they are pre-treat permits and their wastewaters are being discharged to a city, they feel like the city should be able to treat as well and be their backup plan. Unfortunately,
Right. That doesn't work.
That doesn't work.
Doesn't work, yes.
Municipal plants are not set up to treat industrial wastewater. They're set up to treat human waste, stormwater runoff, and restaurant waste, stuff like that, more biologically based. And so in our industry, specifically metal finishing, when we discharge untreated water to the cities, we can wreck the city wastewater treatment plant. We can kill their entire biofilm, biological activity, and then they can no longer do their portion of the treatment safely.
Right. Yeah. It's going to be, it seems like it's going to get very important. And I guess the fallout of this is going to be, you're going to see a lot of more, I'm sure every wastewater, every treatment city in Michigan is now going to pay even closer attention to facilities like plating operations now. So they're going to bring heavy scrutiny. So it's important. This is a very important topic. So let's start off, like I said, 7 things I wish I knew about wastewater treatment. And I think you started to answer it real quickly there, but what exactly is wastewater treatment, and why is it critically important to any of these operations?
So wastewater treatment at its core is the removal of contaminants from water that has been used for some purpose so that it can safely be discharged back into the environment, or it can be recycled back into a useful purpose. For metal finishers, that is the removal of the metals that we have in our wastewater. It's the removal of chelation that ties those metals up. Some instances, it's the removal of phosphorus that can impede a healthy environment if the water is discharged in the environment. So that is what wastewater treatment is. And there's a multiple ways to do it. But like we were talking earlier, it's critical that it gets done. There are rules, regulations, and laws set in place that says if we don't treat our wastewater prior to discharge, we can be fined heavily and possibly go to jail. As you mentioned, the 2 owners of that one facility will be going to jail.
Right. Or excluded from the system, correct? I mean, the one in Michigan, I think they couldn't operate. The city said, nope, you're not gonna give us anything. And so where do you go then, right? You're completely out of business if you don't get it working properly, because you can't tap into the municipal system, correct?
That is correct.
Yeah. So let me ask you, why does it, what makes metal finishing wastewater treatment so complicated for some places? Some do it very well, right? They have systems in place, but why is it so complicated for others to treat?
It depends on what the metal finisher's doing. If they don't have a lot of chelated cleaners, if they're not doing electroless nickel, which is heavily chelated, if they're not putting a lot of organics, if there's not a lot of sterates in their wastewater, it's pretty easy and straightforward to treat. So that's one side of it. The other side is there is no set, everybody has the same discharge when they do a pre-treatment permit. A city in Charlotte, North Carolina may give a nickel plater a limit of 2 for their nickel discharge, 2 milligrams per liter, where a city in Boston, nickel metal plater in Boston may have a limit of 1.5. There's a lot of variances in city to city, state to state, and then a lot of variances in what types of cleaners are these guys using, what types of metal finishes are they doing. With knowing what your limits are where you're at, we have a plater in Michigan that has a zinc limit of 0.4 and another plater in Michigan that has a zinc limit of 2.6.
Right. So what you're saying, so they give them limits, I know, on zinc and nickel and copper and certainly hexavalent chromium. They give them all these limits of what they'll allow, correct?
That is correct.
Yeah, and that's where they've got to meet them. And it sounds to me like what compounds the problem is how the operation comes in and tries to treat these chemicals, which sometimes makes it worse, correct?
That is correct. A lot of times we see guys saying, well, a little bit of this magic dust works. What if we had a whole lot?
Right.
And then they wind up seeing their numbers actually increase because they don't understand that magic frou-frou dust or liquid, right, that they call it, is actually a chelator in itself. So right, it just happens to be stronger than what they already have in their wastewater. Right. So when they add sulfide, sodium sulfide or ferrous sulfate, or they add a DTC or a carbonate, these chelating agents, we call them metal precipitants because they will pull the metal from whatever chelation bond they're in and attach to the sulfide or the carbamate and then precipitate out. But if you overdose those products, then you now have a plethora of still dissolved, chelated in a different way metals that won't come out. So it's a balancing act.
Right. So when you go in to a facility that's asked you all to come in and asked to help out, figure out what's going on, either they've run over some limits. I mean, do you have any clues that tell you whether they're using too much chemicals right away, or is it really, you have to dig down deep into it, or is it pretty obvious that they're using just too much of the chemicals that's causing these additional problems?
Sometimes it's pretty obvious. Sometimes we go in and we'll see in their clarifier the flock will be floating, or the water will be instead of being clear, it may have a tint to it or a smell to it. One thing that a lot of people don't understand is when you overdose chemistry, it changes the feel of the water. So sometimes the water will feel slick or slimy. Even though it'll be clear, it'll still feel off, dirty.
Right, right. Which means it is. It means it is, right?
Yeah, it means it is. So there's ways to tell. Sometimes it's not so obvious. Sometimes it's a fact finding. And we had one instance where an operator would just he was a night shift operator. He would turn up the chemistry at night and they wouldn't see and turn it down before the day shift operators came in.
Right.
And then because the water pushing through wouldn't push through until the day shift operators were on they couldn't understand what was happening.
Right, because they weren't changing anything.
Right.
Ah, gotcha. Question I was going to ask is that, the obvious thing about wastewater is if there's a spill, right? But a lot of times it's just they're releasing it directly into they think they're treating it and they're releasing it into the city's system, and that's where they get dinged on that. But what happens if they have a spill, and what regulations then come into effect? I know they have to report it, correct?
Correct.
They have to report it. Well, then what happens then?
So all manufacturing facilities should have emergency response plans in place that also have a section that covers their wastewater. If they discharge wastewater, what to do when there is a spill. They have a certain amount of time, depending on what is spilled, that they have to contact their receiving authority. So whatever city they're discharging to. Unfortunately, we do have some manufacturers that discharge directly to the environment, and they have to report directly to the state EPA level when they have emergency spills. Then they have to initially, first thing first, shut the system down, block all water from leaving the plant until they can figure out how to solve the problem. Sometimes it's unfortunate that the water that is contaminated has already left the plant.
Right.
And at that point, it's out of their hands. They can't fix it. But if they can catch it before it leaves the plant, stop it from leaving the plant, that's the ideal situation. There's things in place now that wasn't there 10 years ago. We have remote monitoring capabilities. We can set up alarms that tell us our chemical feeds are not feeding properly, our pumps aren't working right. We can set up cameras to watch our discharge pipes and make sure that the water coming out stays the same clarity. So if we employ those and we utilize them the way they were designed, we will see a decrease in these instances of unnecessary spills to the cities.
Right, releases. In the case of the one in Michigan, the reports have come out from the state that the alarms were overridden over 460 times in a matter of an hour and a half. So that didn't work, right? And I know the state and the town there asked them to come up with an immediate plan, which they tied it into their system-wide ERP, which is probably a smart move, correct? So that it cannot be overridden. That if there's an alarm, everybody in the facility, especially those monitoring it from afar, will know what's going on. And that seemed to be the problem here, correct? Is that it was just a localized alarm. But I guess the advice would be to put it into the entire ERP system so everybody knows what's going on.
Right. So we have seen some plants that don't have remote monitoring capabilities, where the alarms only alarm at the wastewater system. And what they've done to combat that is they've put big flashing lights over the wastewater area and speakers throughout the entire plant, so that one alarm, nobody's really worried. But if 4 alarms go off, whoever is running the plant, whether it's the plating line manager or the maintenance manager, the actual plant manager,
now they're going to be aware.
Now they're aware, and they go and say, hey, what's going on? It shouldn't just fall to the wastewater operator to handle multiple alarms. Because sometimes wastewater operators are stretched thin. They're running the plating line. They're taking parts, they're moving parts for the manufacturer around, and they think it's just alarming because it's broke and I'll fix it in a little bit.
Right.
And so they override the alarm.
Well, even if they have a dedicated wastewater operator, correct? A lot of this is sort of the second or third job on the job description, isn't it?
Yes.
It's not the main one, because face it, I mean, a lot of the wastewater lines and systems are supposed to run themselves, right? You don't have to stand there and watch it or turn buttons and things every hour. They're supposed to do it themselves for the most part, correct? Which is why it's not job one for a lot of facilities. They don't have a dedicated wastewater operator. Or do you find that different?
No, you're right. A lot of equipment manufacturers sell wastewater systems on it's going to run itself. You won't have to have someone here to watch it.
And it will run itself
until something goes wrong.
something goes wrong.
So we have an interesting customer in that they don't have one person dedicated to wastewater. The entire plant is responsible for wastewater. They all get notified when an alarm goes off. They all take turns emptying the press, filling up chemical feeds, making down the polymer. Every person who works for them at least once a day puts their eyes on the wastewater system.
Right. It's funny. I've talked to two operators in the past, I'd say 6 months, who both said something to me similar, that they were the head wastewater operator for their facilities. They were the owners, right? Which, now that I think about it, it's probably not a good idea, right? It's got to be a little bit shady that they are the wastewater operator, because you're right. It does need to be, basically when the operation is going, somebody needs to be on the floor available to look at these things, right? That's probably not a good practice, would you say?
I always advocate to having one person dedicated to wastewater. An owner of a facility, if it's a small facility that maybe only employs 10 people, they may be the person dedicated to it.
Right.
Because they don't have enough flexible people. Even though they're the person dedicated to it, though, they should always have two other sets of eyes.
Right, redundancy, right.
A and B, when you hear an alarm, if it happens 2 times within 5 minutes, one of you needs to come help me.
Right. Gotcha. Let's talk about over a general. What would be one thing you would eliminate from wastewater treatment overall? What would be one thing you would take out?
If I could eliminate, I think I would eliminate foam. Foam is a problem that most people don't realize is a problem until they're like, oh my God, that's a problem.
What do you mean by foam? Explain that to me.
So foam forms in manufacturing processes, from cleaning applications, from vibratory applications, and it's important in manufacturing. But what happens is it entraps contaminants in its structure, so that when it gets to wastewater, if it manages to make it through every part of wastewater without breaking down, and it leaves the facility, it still has those contaminants in it.
Is it because it's above the water, the foam? Is that what?
Well, it's because of the structure of the bubble just entraps the contaminants.
Ah, gotcha.
So while it's needed and necessary and wanted in many applications in manufacturing, wastewater is something that we get calls from all the time. I just had a call this week about a company here in South Carolina that has foam tumbleweeds that are just like being blown away from their clarifier across their parking lot.
That's not good. It's not a good sign. Not a good optics to have that. So how do you get rid of foam then?
So there's defoamers and there's anti-foamers. Defoamers are what's typically used in wastewater because the foam's already formed.
Right. And
we add these liquids to make the foam break apart in the first tank of the wastewater treatment system. Anti-foamers can be added to manufacturing processes to prevent the foam from forming or to reduce the amount of foam that forms, say in a cleaner or a vibratory process. So those are two options. Another thing is activated carbon. A lot of municipal plants will use activated carbon if they have a huge increase in foam from a manufacturer.
But and these are products that you all would sell to, be able to put right into the system, kind of eliminates it right away then with that.
Another thing that we see that a lot of people don't realize is if you have a heavy solids load in your wastewater, specifically from vibratory finishing, you will see an increase in your foam formations in wastewater. So you really need to pull your solids out of your wastewater.
I've often heard a lot of shops talk about they would love to go zero liquid discharge. And I'm assuming that speaks for itself exactly what it is. They're not sending anything to the city or the municipal wastewater treatment, correct? It seems like that's got to be very expensive, but what is zero discharge?
So zero liquid discharge is exactly that. When a manufacturer says we would love to go zero liquid discharge, that's our ISO 14001 standard. That's our end goal for environmental. We don't want to discharge any liquid. What that means is they're going to take their wastewater, they're going to remove every contaminant that needs to be removed, and they're going to put it back in process. Mm-hmm. Now, how far down the line do you want to go with that? How clean does your water have to be?
Right.
Do you need deionized water, or would distilled water be adequate? Or do you need tap water clean, which still has some contaminants? Maybe it's not got the same metals in it, and you're going to use it for non-critical rinsing. It can get very expensive very quickly to go to 100% zero liquid discharge. A lot of those types of systems have evaporators, they have membrane filtration, they have distilling units, they have sludge drying units. So each component, can cost a couple $100,000 to build a system like that. So when we have a customer that tells us we want to go zero liquid discharge, we have to really ask them, what do you think that means? What would that look like for you? And maybe it's not 100% zero liquid discharge. Maybe it's a 50-50. Maybe you recover 50% of your wastewater for non-critical buildup of like cleaner tanks. You get it as clean enough to do that job. And then the other 50% you discharge.
Right. Well, water costs are extremely high, right? And a lot of these plants and I read somewhere where, there's only really 3% of all the water on the earth that's available to humans. So it's going to be a priority and a commodity. And in some areas of the country, it's very expensive. And some of these shops are using, thousands of gallons a day. Does that reduce the amount of water that they're using every day, or is it with a zero charge system?
Water recovery systems will reduce the amount of fresh water that a manufacturer is bringing in to make up, whether it be from the city or from a well that they have on site. Water recovery systems are not quite the same as zero liquid discharge.
Right.
And they're not as labor intensive in some cases. It involves running the water through carbon filtration to remove the organics, and sand filtration to remove the solids. Perhaps they're doing some metal precipitation, but if it's mainly from their cleaners and rinses, there's not going to be a lot of that. So those types of systems have a lot smaller footprint. So as manufacturers, we draw the water from our communities, whether it's from the water table, from a well, or directly from the city. It's our responsibility to ensure that we use that water safely and with purpose, and we don't waste it.
Right.
And that we treat it with the respect that I think it deserves.
Right. I was going to say, can there be a return on investment of the zero discharge equipment by saving the water usage? Is there, because I've heard some people say, well, we were using 40,000 gallons a day, and we went down to, I guess if you're zero discharge, you're recouping a lot of that. But is there a possibility to have a ROI that would it would pay for itself, or is that just not? Is it too high of a cost to do that?
What I hear from a lot of our customers when we work with our equipment partners to give them a zero liquid discharge system, all the bells and whistles, they're going to discharge zero. They're going to capture all of the water, all of the steam, is that it is too expensive right now. The technology's just not there. So then we start scaling down things, and we find that comfort level for them where maybe they're recouping 50% of the water. The equipment is within a 5-year ROI, and they're happy with that. Everybody wants to be environmentally sustainable. We want to do the right thing, but at the same time, we have to run facilities. We have to pay our employees. We have to pay our taxes. We have to turn a profit to stay in operation. And we can't spend that entire profit on wastewater treatment.
Gotcha. Last question, just, as we try to solve this problem of wastewater. So, why should a manufacturer care about wastewater treatment? I think we mentioned earlier how, the heavy hand of the law will come down on you. But, why should they care about having a proper wastewater treatment system in place?
For me, we should care because we live in the cities and the towns and the communities where we draw our water and we discharge our water. We don't want to pollute our population. We don't want to kill people. And unfortunately, a lot of the metal finishing processes have extremely toxic chemicals that are used. That's first and foremost why we should care. The second is how do we truly understand our cost to manufacture a part if we don't understand our water cost? If we don't understand 1 gallon of wastewater leaving our facility is equal to $1 of profit or 50 cents of profit. And we do have one customer in Alabama that actually broke down for every single piece that they manufactured, how much wastewater was generated and how much profit that what gallon of wastewater that was generated equated for them as in terms of that actual piece being sold.
Right. Wow. That's detailed. But you got to know, right? You've got to know what these costs are so you can measure, like you said, whether you can afford to improve systems or things like that. So that's pretty detailed.
I think a lot of metal finishers don't know how much water does it take to make an automobile.
Right.
How much water does it take to make a screw to hold a piece together?
Right. They know labor charges, right? They know labor.
But I think we're going to see a shift in thinking in the next few years where labor costs are only going to be one piece of the pie. Labor costs, chemical costs, transportation costs. And then we're going to really start talking about water costs.
Right. Yeah. Well, like I said, we won't even get into, at this point, the new PFAS regulations and how that deals with wastewater treatment, but that's another episode. So we'll get to that. But that's going to be a whole problem in and of itself with that. But anyway, well, listen, Robin Deal, product manager for AquaPure, thank you for joining us today. Much appreciate all that great insight.
Thank you, Tim. It's always a pleasure speaking with you.
Great. All righty. And thank you for joining us, and come back and see us again on another edition of Seen and Solved. Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.